Step 4. Computing the test statistic. Now that a critical region has been determined, the real fun begins. In order to find x squared obtained, the following formula must be implemented using the values from the bivariate table. So the formula is the sum of the observed frequencies minus the expected frequencies squared over the expected frequencies again. Now let's look at an example. In order to find x squared obtained, you will need to acquire the expected frequency for each cell. The formula for this is the marginal row times the marginal column over n. So for an example, for a social worker that is accredited, to find the expected frequency, we would take 40 times 55 over 100. Step 5. Making a decision and interpreting the results of the test. Now that we have both x squared obtained and x squared critical values, we can compare the test statistic with the critical region. If x squared obtained is greater than the x squared critical, then we reject the null hypothesis. However, if this is not the case, then we cannot confidently reject the null hypothesis as implausible. The limitations of the chi-square. While the chi-square is flexible enough to accommodate many different types of variables, it becomes difficult to interpret when the variables have many different categories. As a rule of thumb, the chi-square is easiest to interpret when both variables have 4 or fewer scores. The probability of rejecting the null hypothesis increases as the number of cases increases. Larger samples may lead to a decision to reject the null hypothesis when the actual relationship is trivial. Generally speaking, the chi-square distribution breaks down if expected frequencies are too low. It is still acceptable provided that there are no more than 20% of the events have expected frequencies below 5. Video demonstration. So this video will show how to use SPSS and calculate the chi-square statistic.